People have been observing tides for a long time, and at first, you'd look at the water come in and out, and that was your tide observation. But in time, people, made the connection with the sun and the moon and realized that maybe to understand tides and how they work, it's better to look up at things in the sky. My name's Ben Burris, and I'm a staff astronomer at the Chabot Space and Science Center. Tides are caused by the gravitational pull of the moon and the sun and the rotation of the Earth. The Earth is not a solid sphere like you'd think. It's actually kind of squishy, and especially this layer of water we have on the outside of the oceans. So the gravity of the sun and the moon actually kind of squeeze or stretch the Earth and its oceans out into a couple of bulges. One under the moon, one on the other side of the Earth. And as the Earth rotates over the course of a day, you standing on the surface of the Earth move along with the Earth's surface into these bulges. And we experience that as the rising and lowering tides. But really, we, on the surface of the Earth, are moving through bulges created by the moon's gravity and the sun's gravity as well. Now, it's easy to see how on the side facing the moon or the sun, you could get this bulge of ocean. And you can imagine the gravity pulling the oceans up into a blob or a bubble. But it's not as easy to understand why there's a bulge on the other side as well. And the easiest way to describe that is the moon's gravity is stronger, of course, the closer you get to it. So on the side of the Earth close to the moon has a stronger pull. So while the oceans on the moon's side get pulled more strongly than the general Earth does, on the other side it's kind of opposite. The pull on the oceans on the far side are less than the pull on the Earth. So that far bulge actually gets created, you can think of it as the Earth being pulled out from under the oceans a little bit. So you get 2 high tides a day because as the Earth rotates, we rotate through these 2 bulges. Both the moon and the sun play a part in tides. Each one pulls. And when the sun and the moon combine their forces, that is, when they're both acting together, we get much stronger tides than usual. Higher highs and lower lows, we call these spring tides. The name spring tide doesn't have anything to do with the season spring, but we get them about twice a month at new moon and at full moon, when the Earth, the moon, and the sun are all lined up and the gravity of the sun and the moon are acting together. Neap tide is when the tidal effects of sun and moon are kind of canceling each other out or making each other not as extreme. And that happens around first and third quarter phases of the moon. When the sun is in one part of the sky and the moon is 90 degrees around, and they're kind of pulling in different directions. So you get lower highs and higher lows during the neap tide. Things we've learned about the tides with things like tidal gauges is that tides are actually very complex. And with instruments, we can measure those complexities and learn a lot about not just the sun and the moon, but the Earth and the ocean floor and how water behaves.
That's the San Francisco or Golden Gate Tide Station, the oldest continuously operating tide station in the Western Hemisphere. So it's been in continuous operation since 1854. And it's a very important facility because it feeds us state-of-the-art information using most current technology on tide levels, currents, water temperature. We also have a small weather station attached to it, and also some information on like the surface currents as well as subsurface currents. Most importantly, we're getting sea level information. It has gone from having a calibrated stick in the water, being read, manually by someone every so often, and now we have state-of-the-art equipment. It's all computerized. The data that is fed into it is gathered not only from the station itself, but also from a small breakwater. And what it does is it uploads information via satellite every 6 minutes so that information is near real time. The world's climate is changing, and it is happening at a rapidly accelerating speed, and we need to be right on top of it because the entire Bay Area is going to change. The configuration of the bay itself, the very fact that we have a tide station that is giving us information over a period of more than 150 years is important because we're going to see the short-term changes as well as the long-term changes and then be able to plan our response accordingly. So this is kind of like the front line of our data. As we see sea levels changing, this is going to be a key factor, a key piece of information in determining how those changes are occurring.